So to find the break-even amount, what you've got to do is sub in for n equals 200. And we're going to first of all sub into the equation for calculating the cost of producing the muffins. So we're going to use the equation C equals 0.25n plus 200. And we're going to sub in for n equals 200. And when we simplify, 0.5 times 200 is 100. And so C is equal to 300. We could have also done this by subbing into the earnings formula, which is earnings is equal to $1.50 times the number of muffins produced. And so C equals 0.5n. And so when we sub in for n equals 200, we also get C is equal to 300. So what this means is that the cost of producing 200 muffins is $300. Also, if you sell 200 muffins, you make $300. And here, your costs are $300, your earnings are $300, so you haven't either made or lost money. So your break-even amount is $300. So now we're going to go over how you solve linear systems by substitution. Now the first thing you do is isolate the variable from one of the equations. Next, you substitute the one statement into the other. Third, you solve for the unknown and substitute back into either equation to find the second variable. Now the coordinates x, y represent the point of intersection for a linear system. And at that point, the x is equal to the y for both equations. And it's always wise to check your solution, because if it satisfies both equations, then you know you've got it right. So we'll start by looking at an example. And we want to solve the linear system y equals x plus 1 and y equals 3 minus x. And the first step was we had to isolate one of the variables. And we've done this in each of them, because here we've got y all by itself and we've got y all by itself there. So y is already isolated. So we're done step 1. So we're going to move on to step 2. Substitute one statement into the other. So the first statement is x plus 1, and we're going to sub that in for our y in the other equation. So the x plus 1, because remember that y is equal to x plus 1, and y and the y's here are the exact same. Remember, at the point of intersection, our y's and our x's are equal. So this y is equal to this y. So we can say that if this y is equal to x plus 1, then this y is also equal to x plus 1. So we're going to replace it with x plus 1. So now we have an equation, and so what I'd like you to do is solve for x. In other words, rearrange this equation to isolate x.